Okay, so for this problem about Halloween candy, if we have a total of 7 chocolate bars with peanuts and coconut bars, and then we're also given some information about the grams of fat in these candy bars and told that the grams of fat exceed the daily maximum desired fat intake of 60 grams by 43.1 grams. And then we have to figure out how many bars of each kind were contained in this particular Halloween collection. So there is a lot of information, and I think the easiest way to do this type of a problem is to actually start by putting all the information into a table. So I would start with a table where I say, okay, let's see, what do I have here? I've got chocolate with peanuts and coconut bars. My table actually gonna have to get a little bit bigger. And then I have some totals over here. Okay. And for my first row, I want to record just the actual count. So I don't know how many chocolate with peanut butter bars I have, so I'm going to call that X. And I also don't know how many coconut bars I have, so I'm going to call that Y. But I do know that the totals are 7. The total number of bars altogether in the Halloween candy is 7. And then on my next row, I'm going to organize information given about the fat content. So fat content. And this is actually in grams. So we'll be even a little more specific. And while we don't know how much fat content is in the total amount of chocolate with peanuts bars, we do know that each one contains, from the table that I opened up here, the graph with the chart, that each one contains 16.3 grams. And if I have X of them, I have to multiply that by X to get to the fat content in all those candy bars. And the coconut ones contain a little bit less, 14.1, so 14.1 times Y. And altogether, the totals of the fat content from all of those candy bars that we're eating or collected at Halloween is going to be, now this is the part that we have to be a little bit careful of because it was up here a little wordy. 60 grams is the desired fat intake, and we're exceeding that by 43.1. So this ends up actually being 103.1. So just a little side note on that one. That comes from the total recommended plus the exceeding by 43.1. So that's where we're getting that 103.1 for that guy. All right, so that's what I would do to just get started on my table. And now we have enough information to write our system of equations. So our system of equations is going to be X plus Y, the number of chocolate with peanuts candy bars and the coconut candy bars, and we know all together we've got 7, and then the fat content gives us another equation, 16.3x plus 14.1y, and that is 103.1. That gives me the system of equations, and then I can solve this system of equations using either substitution or elimination. In this case, I think I'll just use substitution since it's pretty simple to solve for y here. We can say y equals 7 minus x, and then we can plug that into the second equation, so 16.3x plus 14.1 times 7 minus x is 103.1. Distribute here 16.3x plus, and we could either use the calculator or multiply that out. That ends up being 98.7 minus 14.1x equals 103.1. And combining like terms, we get 2.2 x plus 98.7 equals 103.1. Subtract that 98.7 2.2x is going to be equal to 4.4. Convenient, because now when we divide by the 2.2, we actually get a whole number of candy bars. 2 of those chocolate with peanut butter candy bars. And then we can solve for y by plugging back in, and y ends up equaling 7 minus 2, which gives me 5. So we have 2 chocolate with peanuts and 5 coconut. And there is our answer. So while it's a lot of information, once we got it set up into the system, we were able to solve that just using substitution. We could have used elimination. But organizing the information you have to sort of sort through all that information, and I find using a table can be helpful. Okay, there we go.